Hello and welcome back to our series on electromagnetic waves. Um, just to quickly summarize, we've looked at the electromagnetic spectrum. Generally speaking, we looked at the different um, wavelengths that are on the spectrum, and then we decided to take each one of them. And the first one we looked at was the long waves and radio waves. We looked at the properties and applications of long waves and radio waves. And the next after that was we looked at microwaves. We looked at the properties and applications of microwaves, and we were able to identify microwaves as being a wave that has more energy than radio waves. Today we're going to be looking at the next one on the spectrum. So if you look right here, you can see the radio wave is right here, the microwave is right here, and the next one we're going to be looking at is the infrared wave. Now the thermal and the infrared are pretty much the same. So we're going to be looking at the infrared waves and its applications today. Infrared radiation is usually known as heat radiation because that's the way we identify infrared. So pretty much any object that is able to produce heat is actually radiating through the infrared spectrum. So it's producing infrared waves as well. Okay, and so that's how an example, of course, would be the sun. The sun produces heat, but it's not the only source of heat. Humans, living things generally also produce different degrees of heat. So we're also sources of infrared radiation as well. All right, so like all the other electromagnetic wave, infrared wave from a one-dimensional shape actually looks like a transverse wave, just like the previous ones before it, radio waves and microwave. However, when it comes to the length of the wave, it's much shorter, way shorter than radio waves or microwave. The range is between 10 to the negative 7 meters to 10 to the negative 3 meters. That's how short it is. Consequently, it has a high frequency. Remember what we said in our last lesson. The shorter the wavelength, the higher the frequency. So the frequency of infrared is very high. The range is between 10 to the power 9 hertz, that's 9 zeros, 10 to the power 9 hertz to 10 to the power 12 hertz. So you can see that this is a very high frequency. And if you can also recall, when we said that the higher the frequency, the greater the energy. So if you take a look at this here, this would represent a radio wave. It has some energy based on the size of the muscle. This here would represent microwave. It has more energy than radio waves, right? So microwaves and radio waves. Well, infrared would be something like this. It has way more energy than radio waves and microwave. Okay, so what that means is that infrared wave is able to penetrate objects more than radio waves and microwaves. Not only that, is infrared can also cause more damage to tissue. So, which is why, of course, one has to be very aware because it can cause damage to the tissue. Like, if you're when you're tanning in the sunshine, you want to be careful how much you get. What what you're essentially doing is you're having the darkened skin cell, and that's actually a partial burn going on in your skin cells. But the more it happens, the more damage into your skin tissue.
We're going to look at the uses of infrared waves. Okay. Um, the first the first type of application would probably be in night vision. You probably have heard of night vision goggles, night vision telescopes, and these are instruments that allow us to see at night. Okay, this is probably an image of a night vision uh, binoculars or goggles that allow you to subject. You're able to see both uh, living things and non-living things as long as it produces some heat. This instrument can not only detect the object but is actually able to form the shape of the object as well too. Now another which infrared is used, it's used in what we call thermography. Now thermography is the science of detecting the temperature, remotely in the temperature of an object, both things and not. If you take a look at this object right here, you might be wondering what this is. Well, this is actually a snake eating a rat. Here is the head of the snake. If you're looking at this head here, if you look at the, see that the temperature is around maybe 1 degree Celsius. Now take a look at the rat. You can see that the rat has a higher temperature because it's warm-blooded, so it has a higher temperature than the snake, and temperature is probably around 20 degrees or higher. So that thermography allows us to be able to remotely detect temperatures of just living things. We use it to detect those of distant objects like from stars, planets. So very good application of infrared. Also, infrared is used as a tracking or homing technology. In other words, it's able to track objects. An example in its application, here is a missile, and this is what we call a heat-seeking missile. What it does is it's able to track any object, like for example, a jet, an aircraft, a military, any object in heat. This missile can home in, recognize the heat signature, track it, and won't stop until it actually hits the object. So that's a military of. In conclusion, to quickly summarize, like that infrared has wavelength than radio microwave. It has a higher frequency than radio and microwave, therefore energy than radio and microwave. It's night vision, but mostly it's used as tracking and home. So let's quickly check for understanding here. The first question here says, what is the wavelength range of infrared? What is the wavelength range of infrared? Next question says, what's the frequency range of infrared? And then it says, give 2 examples of applications of infrared. So you have to give 2 examples. And then it says you should rank radio, infrared, and microwave from greatest to least energy. So rank them from the highest energy to the least energy. And then give an example of a military application of infrared. So hopefully you understand the series we just covered, and you're able to answer all those questions. Thank you very much for listening.